So, welcome to Ascending Grades. This is just a Form 2 exam, end of term 3. Therefore, we are going to start with question 1. You can still find us through our YouTube channel, Ascending Grades Online School. So this paper will be uploaded there later on. We shall be getting the link as soon as possible. The paper will also be shared unto you. Question 1. A student use the measuring instrument shown below to measure the thickness of a cylindrical wire. You're told that if the wire is 10 centimeters long, then find the volume of the wire. So the first thing, you are supposed to get the diameter or the thickness of the wire. So what will be the thickness or diameter of the wire? So we're going to make reading using this one. This is a micrometer screw gauge. Then you can see we are having the 0 mark there. So it means that we shall be having 1, shall be having this as 1 and this as 2. This will be halves. So the main scale reading, so we are doing now the reading. So the main scale will be giving us 2.5. Then our vernier scale will be giving us, you can see it is aligning with 45th centimeter mark. So it will be 45 times 0 0.01. So you get 0.45. So that you get 2.95. And this one is in millimeters. That one is in millimeters. Okay. So now we must get the volume. So what will be the shaping of this wire? It will be in this manner. So now we have got the diameter. We have the length of 10 centimeters. So we know that volume will be given by the cross-sectional area pi r squared times the length. So in this case now, we convert these 2.95 to centimeters. So divide by 10. So otherwise, this one will be the same as 0.295 centimeters. So we substitute here. So our pi to be 22 root of 7. So we get the radius by dividing this one through by half, 0.295. Then we square it. Then times 10. When you compute all this, you're going to arrive at 0.6847 centimeters cubed. The load carried by a truck loader was measured to be 65,000 grams. Convert the mass of the load into milligrams and express the answer in standard form. So 1 gram is equivalent to 1,000 milligrams. So what about the 65,000? So this becomes 65,000 times 1,000. You get 65 million milligrams. Then we have an instruction where we are told that you need to give it in standard form. So this will be 6.5 times 10 raised to power 7 milligrams. So you're going to count, you cancel the zeros, you count all of them, then you'll arrive at 6.7, and then you'll find that you are having 10, that is 7 tenths. That is why we write 6.5 times 10 raised to power 7. From 2 gal, from 1, observed that when mercury is put into a glass, it does not wet the glass. Then we are told explain this observation made by this girl. So you're supposed to explain this. The issue to do with the mercury, it's all about the forces acting on it. So it has stronger cohesive force. It has stronger cohesive forces. holding the mercury together. Hence, do not wet the glass. Hence, do not wet the glass. Well, in case we want to see some further elaboration, then we shall give an elaboration like this. That when we are having mercury, then it will be of this shape. This is mercury. And now we have now the one for water. So the shaping of the water is because it has stronger adhesive force with the part or the surface of the glass. In using lift pump to raise water from a borehole, it is observed that practically the height the water is raised cannot be 10 meters and more. So you can talk of 9.8 meters, but not exactly 10 and above. Give two reasons for this observation. Number one, the lift pump uses the concepts of atmospheric pressure which supports only about 10 meters of water column. Then number two, thank you, Gideon. Due to leakages, in the valves and the pistons. So we have question 5. It is from the Hooke's law. And it reads, when a mass of 2 kg is hung from a single spring. So the first part is we are having 2 kg with a single spring. The spring extends by x. So the extension for this one becomes x. Then you are told determine the total extension in the setup below. So we should be having something here. A condition of the springs are identical. So that you can be able to respond and to read. So if a single spring extends by x, then these two which are in parallel, they are going to extend by half x. And then the last one will be extended by x. So the total extension will be x plus x plus half x. Now this one you get 2.5 x, which is 2.55 x. So that will be the extension. State what is meant by streamline flow. Is a type of flow is a flow in which all the particles of a fluid move in the same direction at the same velocity. The figure below shows the cross section of an aeroplane wing. So this is what we call aerofoil. With the plane moving in the direction shown below by the arrow. So this is the direction. Then you're asked, sketch the streamlines to show how air flows past the wing as the aeroplane moves. Before drawing, then you must understand that this one is it's supposed to be helping the plane to move upwards, meaning that at the top we shall be having low velocity. Sorry, supposed to be high velocity. High velocity. Then at the bottom, we have low velocity. So this one will give in turn low pressure, and this one will give high pressure. So it is going to give the plane an upward move. So the moment we are drawing the streamlines, we are supposed to show weak streamlines above the head of foil. So show weak streamlines above. And how do we show these ones? Ensure they are spaced. While at the bottom, we show strong streamlines. And this one, they will be meaning that they are very close together. So we space the upward ones. And then the lower ones, they are supposed to be close. The spacing must be very close. Then you show the direction. we have part C. The diagram below shows two horizontal pipes, A and B. Tube A contains liquid at rest, while B contains liquid in motion. Then you're told sketch graphs for A and B to show variation in pressure. So now, can you go on? We discuss part A, the one at rest. Then you can see we are having the same levels of the liquids. Then we expect the pressure to be just flat. The pressure is not changing because the liquid is at rest. But when you look at the one in B, the pressure will be reducing with distance. So how are we supposed to say or ask ourselves in which direction was the fluid moving in? It's like we are being asked about the atmospheric pressure because we cannot see the direction in which the motion of the fluid is about to. So if you see that this one is rising above, then it means that the atmospheric pressure here is being reduced. So we can say from the original pressure when it was at rest, then it means the pressure will be reducing like that. Explain why ethylated spirit at room temperature, when dropped at the back of the palm, makes the palm to feel very cold. Uh-huh. So how are you supposed to respond to this one? The concept being tested here is for physics form 3, but you can just give it anyway. So, ethylated spirits, ethylated or methylated, whichever the case, is very volatile. is very volatile. Volatile means that it can evaporate with a lot of ease, very fast. Then you can say it absorbs latent heat of vaporization from the ants, causing cooling effects. You have our question 8. A block measuring 20 centimeters by 10 by 4 rests on a flat surface. The block has a weight of 6 newtons. Then we are told, determine the minimum pressure as the first question. So this is from one work. Minimum pressure will be given by force over maximum area. So maximum area in this case will be given by 20 times 10. 20 times 10, and this you get 200 square centimeters. Now we have those people who cannot see clearly from the question. So let me just draw. So 20, 10, we have 4. Like that. So we are given already the weights. So our minimum pressure will be given by a force of 6 newtons divided by 200 as the area. So we convert this one into square meters, where we are going to divide by 10,000. And this becomes 0.02 square meters. So we have one guy who has already got the answer. That is 300 Newton per square meter. Thank you, Gideon. Part B of the same question, you are asked to determine or find the density of the block in SI unit, kilogram per cubic meters. So in this case, we already have the measurements, that is of 20 by 10 by 4. This one you're going to get this 200, 800 cubic centimeters as the volume of the block. Then now, from the weight, we can get the mass. So mass will be given by the weight over G, and the weight there is 6 newtons. So from the question here, we can change this one. G is equals to 10 newtons per kg. So 6 divided by 10, you get 0.6 kg. If you convert this one into grams, then you multiply by 1000. So you get 600 grams. Then you say density is given by mass over volume, and the mass here is 600 grams divided by a volume of 800 cubic centimeters. So this one goes ahead to bring us by 2, 3 by 2, 4. So this one is 3/4, which is same as 0.75 grams per cubic centimeters. But the question is demanding us, we give in kilograms per cubic meters. Therefore, you multiply by 1000, then you get 750 kilograms per cubic meters. It is easier to work with grams per cubic centimeters. Then you convert them back to kilograms. State the kinetic theory of matter. It states that matter is made up of small particles which are in constant random motion. Why is smoke preferred to use in the smoke cell experiment? We can give several reasons. Number one, smoke particles uh, have the same density as air. That is why it floats, floating in air still. Number two, smoke particles are visible. Smoke particles are visible. C, explain the cause of random motion or smoke particles observed in Brownian motion using a smoke cell. You can say they are continuously hit by invisible air particles which are in continuous random motion. So that is why you can see them in sunk motion. This motion is created by the invisible air particles. Then you need to be very careful. You may see my hands are being very brief, but I will be awarded 3 marks. So the first thing is they are being hit. You can also say they are being bombarded. And then I must describe the air particles. They are invisible. And then they are in the continuous random motion. So first mark, second mark, third mark. Question 10. In the figure below, a uniform bar of length 1 meter. So this is about 100 centimeters. Pivoted near one end. The bar is kept in equilibrium by a spring balance is shown. So this is the setup. Then you are asked, given that the weight of the meter is 1.4 Newton, determine the reading of the spring balance. So you analyze the question. From this side, we can say our midpoint is at this point. Then we have the action of the weight, which is 1.4 Newton, and it is acting at 50 centimeter mark. Then you can say the clockwise moments is equals to anti-clockwise moments. So in the exam, you write in full. So we must look at the perpendicular distances. So the weight of 1.4 times a perpendicular distance, if from this part all the way to this part is 50. So what is the difference in between? So we expect to have 30 centimeters, which is 0.23 meters, is equals to, we want this one to be of F, a force of F, that is the reading of the spring balance, times the perpendicular distance from the pivot. So, so still from here up to this one, we have 50, meaning that from the spring up to where we have the midpoint, we have 40. So 40 plus 30, you get 70 centimeters, which is 0.7 meters. So we make F to be the subject formula, which will be 1.4 times 0.3 divided by 0.7, and you get 0.6 newtons. You get 0.6 newtons. State the property of light associated with formation of shadows. Shadows are formed when light paths or light rays are blocked by an object. And this shows that light travels in a straight line. So you can either say the rectilinear propagation or light travels in a straight line. Like that. Our question 12. Explain why soft iron keepers are suitable for storing magnets. They are easily magnetized and demagnetized. Like that. The figure below shows a conductor carrying current placed in the magnetic field of two magnets. Complete the diagram by showing the field pattern and the direction of force F that acts on the conductor. So you can see the current is pointing out of, assuming that what is appearing on your screen is just a paper, then it is showing that the current is out of. So in this case, we're going to apply the Fleming's left-hand rule. So if you apply it, you'll find that the motion will be moving upwards. That is the force. Then because you have known the force from placing your left hand on this diagram, then now the second mark will be for you to draw the field lines. So because on the top we expect a motion, then we shall say the field lines at the lower part will be stronger than at the top. So they will be somehow close together like this. Then at the upper part, we expect the field to be weak because it is the conductor is being pushed upwards. So the drawing like that will be very much okay. So we can indicate that we have strong fields and we have weak fields. State two quantities that are used to determine whether accumulator require charging or not. We have relative density and we have the voltage output. So now we need to specify about this one. For it to be recharged, then when the relative density falls when it falls below So now we can continue. We had some hiccups. So we are talking about when an accumulator requires charging or not. And then we said when the relative density falls below 1.15. What about the voltage output? Now this one, when it falls below 2 volts per cell, it means that it requires to be recharged. Now we can move to question 15. You are given a figure there. It shows image I. It is from a convex mirror. Then you are told complete the diagram to show the position of the object. So you can see this is the reflecting surface. So when you are drawing ray diagrams, when you are drawing ray diagrams, I'm being in challenge of some network. So the first ray close and parallel to the principal axis. Then for this convex, it appears to diverge from F. So here we go. Mhm. I think there is an error here. It's supposed to be of a concave mirror. Or the drawing of the mirror is the one that was wrongly placed. So if we maintain to have the convex, then we can draw the mirror like this. So now here we'll be having a nice way to go. So array that is close and parallel to the principal axis, then it is said that it appears to diverge from F. So this is how it is going to appear to diverge. So it's supposed to be dotted. So if I was to pick that this is the straight line, then at this juncture, that would become the reflected ray. So this is now my mirror. Then the incident ray would have been in this manner. Then the second ray will be a ray that is passing through the center of curvature. So this becomes my ray. I may not be so much accurate. Mine is not so much accurate. But I'm just guiding you how you can draw it. So these two rays here are meeting at this junction. Then this becomes my object. Oh, so don't forget to show the ray direction. This one could go and come back. So during marking, we expect to show this one, show that one, this part, then this part. So how many are they? They are supposed to be 4. So that it would be 4 times a half, you get the 2 marks. We have taken a lot of time there. This is because of the setting of the question was wrongly drawn.
Business management.
Question 16. The figure below shows a displacement time graph for a wave with a period of 0.5 seconds. Then you are told calculate the velocity of the wave. So you're told the period here is 0.5 seconds. So now what you need to get is, you can either first calculate the frequency or use the 0.5 with the wavelength. So I'll go as by my option. So you can have case 1, use velocity is given by distance, and in this case we're going to use wavelength of period t. So what will be my wavelength here? They are not clearly showing what the 30 means. One, two, three, 4. 4.5. You can see in our diagram, we are having 4.5 complete wavelengths, 4.5 complete wavelengths covering a distance of 90 meters. So what about a single wavelength? Itakuwa ni ngapi? So it will be 1 times 90 divided by 4.5. Let me compute. Then it means that wavelength is 20 meters. Wavelength is 20 meters. So I substitute here and say 20 divided by 0.5. You get 40 meters per second. Or case 2, you get frequency, which is given by 1 over t, that is 1 over 0.5. And this gives me 2 Hertz. Then from the velocity is given by f lambda. Then we say it is 2 times 2 times 20. You still get 40 meters per second. So we have these 2 options. Question 17, we are told the figure below shows part of Burette scale after 200 drops of olive oil were run out. The initial reading was 15.55 mils. Then the first question we are asked, determine the volume of the 20 drops. So what will be the volume? You can see we are having a final reading. So we must first check the scaling. So if this is 15, 15.5, 16. So we read at the meniscus. So this is 15.6. So volume of the drops is 15.6 minus 15.5. You get 0.1 ml. So this is also the same as 0.1 cubic centimeter. Wale huwa wanachanganyikiwa na cubic centimeters, mLs, they are all the same. So that is the volume of the 200 drops. Then part B, okay, you are told when a single drop, now we are referring to A, when a single drop was allowed to spread on a careful prepared water surface, it made a circular patch of diameter 31. So what will be the area of the patch? The area of this patch? Area, it is in circular manner, so it is given by pi r squared. From the computing, you get something that is 755.07 square centimeters. An estimate for the length of the half-life molecules to three significant figures. So the length is like you're being asked about the thickness. So Roman 2 tutaifanya hapa. So we know that the volume of oil molecule, oil drop, sorry, is given by There is something missing. Rangi hivyo. So it is said thickness is given by volume of drop over area of patch. But we got a volume of 200 drops. So 200 drops, they gave us a volume of 0.1 cubic centimeters. So one drop will be 0.1 divided by 200. And this is going to give us 0.0005 cubic centimeters. So volume of the drop is 0.0005 divided by area of 755.07. And this one I'm going to get 6.62 times 10 raised to power -7. And it will be in centimeters because we're looking at the thickness. So we have the last question on question 17. Assumption. The oil patch is 1 molecule thick. You can say oil drop is spherical. Be very careful when you're mixing this. Talking of patch, and this one is oil. Our next question, that is question 18. State any two differences between image formed by plane mirror and pinhole camera. So we can have plane mirror and we have the camera here. So by plane mirror, the image is virtual. The other side, it is real. it is upright here or erect. The other way, it is inverted. Same size as objects. And this other side is varying. It varies depending on the object's distance. We are almost done. The diagram below shows a positively charged rod brought close to two metal spheres on insulating stands. This is charging a body by separation method. Describe how you would use the rod to charge the two spheres. So, while the rod is in position, separate the spheres. Then remove the rods. So at long last, B will go with the negative charges, whereas A, it will go with positive charges. So during this method of charging, both charges are acquired. State two defects of a cell and how they are corrected, or how can they be minimized, corrected or minimized. So you can say we have polarization, and this is the production of the hydrogen bubbles on the copper plates. So thank you. You can see Gideon has said local action and polarization. It's okay. So polarization is done by use of a depolarizer, but be very careful when you are giving the depolarizer. Don't just write the depolarizer, but be specific. So we have potassium dichromate. So kama answer sasa ndio imekuishia, now you can rise the depolarizer. But avoid this. Then we have the local action. Is the eating away of the zinc plates, and you can use a pure zinc, or you do something called alma al even when I'm teaching, I usually skip that part in pronouncing it. Amalgamation. So this is coating zinc with with mercury. Then we have the last question. The figure below shows two bar magnets holding steel pins and placed side by side. Then you ask, what will be the polarities of A and that of P? The first thing that you need to understand from this one is this one is a south pole. So it is going to induce a north pole here. So this one automatically becomes a south pole. And then if this one can be attracted to this, it means this one is north pole. Going backwards, this becomes south pole. This one becomes north pole. So south pole, north pole. On the axis provided, sketch a graph of volume against temperature of water from 0 degrees Celsius to 20 degrees Celsius. So the test here is the behavior of water at 4 degrees Celsius. So instead of expanding, then it will be decreasing in volume. So that is how it will be.